Hi and welcome everyone to one more lecture of probability and statistics. Today we will learn about normal approximation to binomial distribution. Let's say we have a binomial distribution x is random variable n is number of trials and p is probability of success. Q equals to 1 minus p, and this is probability of failure. If n is indefinitely large, that means n tends to infinity, and p and q are not so small, means p, q not so small, that means they are significant. Then our binomial distribution will be an approx to normal distribution where mu will be equal to np and sigma square variance will be equal to npq and standard normal variant z will be equal to, as we know it is equal to x minus mu by sigma, z will be equal to x minus np divided by under root npq. Now, this approximation will be good enough if np and npq both are greater than or equal to 5. Then this approximation will be very good enough. Now, if we want to find out probability of x equal to small x, then this probability will be equal to x probability of x minus 0.5 less than capital X less than x plus 0.5, because as we know in binomial distribution this is a discrete probability distribution and our normal distribution is a continuous probability distribution. So to overcome that, for continuous we will have probability like this, and if we want to find out probability of x less than equal to x, then this will be equal to probability of z less than equal to x minus 0.5 minus np divided by under root npq. Sorry, less than x. And if we want to find out probability of x less than equal to x, then this will be equal to this probability plus probability of x equal to x. So this will be equal to probability of z less than x plus 0.5 minus np divided by under root npq. Similarly, if we want to find out probability of x greater than x, then this will be equal to probability of z greater than x plus 0.5 minus np divided by under root NPQ. And if we want to find out probability of x greater than or equal to x, then that will be equal to probability of z greater than x minus 0.5 minus np divided by under root npq. Now in simple way we can write this as, if probability of x equal to x is included, then we will include the interval probability of z x minus 0.5 minus np divided by under root npq less than x plus 0.5 minus np divided by under root npq. And if this is not included, we will not include this interval. Now we will solve a question. Our question is, probability that a patient recovers from a rare blood disease is 0.4 if 100 people are known to have contracted with this disease. Find probability that fewer than 30 would survive. We have to find out if x is number of people to survive, then we have to find out probability of x less than equal to 30. Now, initially this was a binomial distribution, but now we have to solve it like a normal distribution. Our n equals to 100, p equals to 0.4, and p will be equal to 40, and npq equals to 100 into 0.4. q equals to 1 minus p, that means this will be equal to 0.6 into 0.6. So this will be equal to 24. Now our both np and npq are greater than 5, so our approximation to normal for binomial will be good enough. So we have to find out probability of x less than equal to 30, that will be equal to probability of z less than 30. So this will be less than 30 minus, this is not, 30 is not included, so minus 0.5 minus np. np is 40 divided by under root npq, under root 24. Now, if we will solve this, so this will be equal to probability of z less than 30 minus 40. So this will be minus 10.5 divided by under root 24. If we will solve this value, we will get minus 2.14. Now if we will draw graph for normal distribution, let's say here is z equal to 0 and here somewhere is minus 2.14. Now we have to find out this probability of z less than minus 2.14, and we are given with probability of z greater than minus 2.14, this whole area. Now we know this will be equal to 1 minus probability of z greater than minus 2.14, 1 minus 0.9838. So this will be equal to 10 minus 8, 2, 9 minus 3, 6, 9 minus 8, 1, 9 minus 9, 0, 0.0162. This is our answer. Our next question is, an MCQ quiz has 200 questions, each with 4 possible answers. of which only one is correct. Find probability that shear guesswork is from 25 to 30 correct answers for 80 of 200 problems about which student has no knowledge. So there are 80 questions about which we do not know anything, and we have to get 25 to 30 correct answers from these 80 questions. Now, number of questions 80. Probability of getting right answer, probability of success is 1 by 4 because one of the 4 options is correct. Now we have to find out probability of 25 less than equal to x less than equal to 30. Now, as we know, this of guessing an answer will follow a binomial distribution. So this will be equal to summation x equal to 25 to 30 bx. N comma p are parameters. N is 80 comma 1 by 4. Now, if we want to approximate it to normal distribution, then we must have NP and NPQ both greater than or equal to 5. Our NP will be equal to 80 into 1 by 4, that is 20, and NPQ will be 80 into 1 by 4 into 3 by 4. So this will be 80 by 16 into 3. So this will be 15. Now sigma square is 15. Sigma will be under root 15. Now mu equals to NP and that equals to 20. Now if we want normal variate, so this will be z equal to x minus mu by 30. We want to find out probability of 25 less than equal to x less than equal to 30. Now if this is x1 and we want to change this into standard normal variate z, then z will be equal to 25x minus mu divided by sigma, and 30 will be equal to, here will be minus 0.5 minus 20, and this will be 30 plus 0.5 minus 20 divided by under root 15. So these are our values for standard normal variate as limits. So this will be equal to probability of z less than 30 plus 0.5 minus 20. So this will be equal to 10.5 divided by root 15. Now this 25 minus 0.5 minus 20, this will be equal to 4.5 divided by root 50. Less than equal to less than equal to. Now this value equals to this, and if we will solve this value, we will get 1.16, and if we will solve this value, we will get 2.71. Now we have to find out probability of 1.16 less than equal to z less than equal to 2.71. So this will be equal to, if we will draw a graph, find relation. Let's see, here is 0, here is 1.16 and here is 2.71. We want to find out this area. Now we are given this whole area till 2.71 as 0.9966 and this area till 1.16 as 0.8770. So if we want to find out this area, this will be equal to probability of z less than 2.71 minus probability of z less than 1.16. So this will be equal to 0.9966 minus 0.8770. So this will be equal to 6 minus 0, 6, 16 minus 7, 9, 8 minus 7, 1 and 9 minus 8, 1. 0.1196. This is our answer. That's all. We will meet in our next lecture. Thank you.